So I'm Daniel Lebrero. I'm a technical architect at IG, and we are here to talk about REPL-driven development. Now, before we get started, I have a confession to make. On my very first job, I got to work with 3 technologies that made a profound and lasting impact on my career as a developer. Those 3 technologies were Netscape, Internet Explorer 4, and Internet Explorer 5. Thanks to those 3 technologies, I decided to become a back-end developer, and I have been avoiding any kind of front-end work for a lot of years. And I have been a very happy Java developer, living in a world of JSON and XML. But on a recent project, I got to work again, hand in hand, with a group of front-end developers. And since that project, I have to confess that I'm very, very jealous about the front-end developers. You may be wondering, why is this? Maybe the JavaScript that they learned 15 years ago was somehow different from the one that they are using now. And to be honest, it has changed a little bit, but at its heart, JavaScript is still the same. Maybe they have had time to fix all those incompatibilities between different browsers that used to drive me mad, but it doesn't seem so. So to understand why I'm really jealous about the front-end developers, let's look at a picture of myself doing some front-end work. That's me trying to get a 2-column layout working on Internet Explorer and Opera at the same time with 2 different screen sizes. And as you can see, I'm not very good at it. And as much as I try and I try, I always end up with the same result. That is just a big pile of crap. But even CSS doesn't make any sense to me, there is something really nice on that picture. So let's look at it again. Focus on Mr. Griffin's workflow. See how he pulls from one string and he sees straight away, without any delay, what's the effect on the blind. And if he doesn't like what he says, he just pulls the string in a different direction. And he just keeps doing that until he's done. And it's this immediate feedback what I really, really miss on my day-to-day work. And we know from Agile and Scrum how important feedback loops are. But why an immediate feedback loop is so important for us during development? Without that immediate feedback loop, it's very difficult to get into the zone or the flow. The zone is that state where you feel like Neo when he comes to realize that he's the chosen one. When you are in the zone, you are so focused that the real world disappears, and instead is replaced with your code, its design, and the data flowing through it. When you're in the zone, no problem is hard enough, no bug can hide from you, and your solutions are simple, clean, and elegant. When you are in the flow is when you are the most productive. And it's not just that you are able to produce more. What you produce is of a better quality. But this productivity is just a side effect of being in the flow. What we are looking for is that feeling of joy, that feeling of achievement, that feeling of creating something truly beautiful. And it's this feeling why I am, after 16 years, still a developer. But we all know it. We are there in the flow, doing all of our tips and tricks, and then, and what happens? That's how much it takes to take you out of the flow. And we middleware developers are expert at these kinds of interruptions. We even have comics about it, right? We are so used to it that we think that it's the way it has to be. But if we look at what the usability expert says, is that to not lose your train of thought, your interruptions shouldn't be longer than 1 second. And who is able to build and start an application in less than 1 second? So while preparing the presentation, I created a completely new application using IG's archetype, completely new, just 1 controller and 1 test, and I tried to build it and start it. How long do you guys think it took to build and start the application? Who wants to give a guess? No, more? It took 30 seconds. Is 30 seconds a reasonable amount of time to wait for an application to build and start? So let's think for 30 seconds, about 30 seconds, OK? Are we ready? 30 seconds. And this is for an empty application. And I don't know how it feels for you, but for me, standing up here, those were very, very long 30 seconds. And we do this all the time. But we have learned to not do this. And if you follow the advice of that really wise man, you try to avoid running the application completely, right? You try just to use TDD as much as possible. But if you have been doing TDD long enough, you know that TDD has some shortcomings. So the first shortcoming, what's in common between all those four guys, between mocks, fakes, stubs, and spies? What are mocks? Mocks are just lies. What are fakes? They are all lies, right? They are lies that we have to create to make us sane, to keep our workflow that we get that really fast feedback. And we cannot avoid them, but what we want is credible lies. Yeah? We want things that we mock that look as similar as possible as the real world thing. But how do you understand how the real world works? The only way is to run a little bit of code. Just to understand how a third-party system is going to work, the only way that I know is to either read the documentation, which usually doesn't work, or you just go and just poke at that third-party system. And to poke to that third-party system, TDD doesn't give us any tool. To know what's in a database, what kind of data is going to be there, what kind of tables, there's nothing that TDD gives us any tool. And the second thing that I have found that is true, if you do TDD, is that no matter how much code coverage you have, once you run the application, you are going to find some bug. Yeah? Maybe your configuration is wrong. Maybe your spring wiring wasn't completely correct. There is always going to be something that you didn't thought about. Yeah? So what kind of workflow do we want? We want to be able to write code and get an immediate feedback. We don't want to be building and deploying and waiting for it. We want an easy way of creating those lies that we are going to use during our testing. We want some kind of tool to understand how the real world is going to work. And we don't want any kind of surprises when we start the application. So of course, we are going to use a REPL to fulfill all these options. So REPL stands for Read-Eval-Print Loop. And we have all used REPL in one shape or another, usually as a command line interface, right? So a command line interface is just a REPL. You type there one of the commands. The command, it's evaluated, and the result is printed back. And then you loop. You can put another command. So we are going to be doing this. But the only difference is that instead of typing Unix commands, what we are going to be doing is writing small pieces of code that we are going to be evaluating all the time. So for the demo, we are going to start a Maven process. We use Maven. We like Maven. Maven is going to start a Tomcat. The Tomcat is going to start our application. That is just a usual war. And inside the war, we are going to start a REPL, yeah, that command line. But because it's very cumbersome to have to type all your code in that little window, what we are going to do is we are going to attach a socket to that REPL. And from our IDE, we will connect to that socket, and we'll be typing code in the IDE where you always type code. And we will send the code to the REPL, which will be evaluated in the application, and the results will be printed back in that window over there. OK? Cool. I'm going to use Clojure for the demo, but the language is not important. What I want you guys to focus, it's on the workflow, on how you will go on your day-to-day work about doing what we are going to be doing during the demo. And I want you to compare how easy or how fast is the feedback that we get using a REPL versus how long it will take you at work. OK? So don't worry about the language. I don't expect anybody to understand anything. But one of the nice things about a REPL, one of the things that enable, it make it easy to learn a language. Yeah? It make it easy to play with the language and to learn to use some libraries. So the first thing that we are going to do is we are going to spend like 2 minutes just doing some Clojure so you get a little bit more familiar. And let's go for it. So the first thing that we are going to do is we are going to start the application. So I don't know when you have to build a new piece of functionality, how you go about, but during REPL-driven development, the thing that we do just when you get to work is just to start the application. Yeah, so that's slightly different from the usual workflow. And this is the bit that is going to be the slowest. So it usually takes around 30 seconds, so it's the usual build time. Now, this thing is something that you will do maybe once a day, once a week, once a month. I have had a REPL running in my local PC for more than a month. And it just depends when you need to change projects. Yep, so we have now the application up and running. So what we are going to do is from IDEA. Everybody happy with IDEA? We are going to connect to that server. Yeah? So here's IDEA, the usual file where you will type your production code. And this is the window where the results are going to be shown. Yeah? So just to get used to the workflow, what I'm going to do is I'm going to call one function, and I'm going to use a shortcut to evaluate it. But that was fast. So what we are doing is, this is the piece of code that we evaluated. This was sent to the Tomcat. The Tomcat did that math, 1 plus 3. And this is the result that we got back from the Tomcat. Yeah? So remember that this piece of code is being run or executed on the Tomcat. Yeah? Sounds weird? So to explore a little bit the language, for example, if you want to know what happens if you, instead of 2 parameters, we call plus with 3 parameters, we just add another parameter, and now we just try it. So again, one shortcut. The expression, this piece of code, is sent to the Tomcat evaluates it, and we get back the result. So we see that we are getting an 8. And if we want to know what happens if you just pass 1 parameter to plus, again, shortcut, we send the code, and we get the result back. So this is a nice way of exploring a language. And the same way we are doing it with the plus function, you could create new functions, you could test any library, you could do anything with it. OK? Enough Clojure? Yeah? That's enough? So this is just to get used to the flow of me typing something, and then some magic happens. I press a shortcut, and the results appear here. OK? Everybody happy with it? Cool. So what we are going to do is we are going to build a Tomcat service, a RESTful service that what it's going to do is go to database, get some list of transactions for a user, and it's going to do some summary, and it's going to return that. So the first thing that we need to do is we need to understand what's in the database. Where is the data? We assume that the data is there. So we know that there must be some table or some store proc to get hold of that data. So how I will usually go about it is I will open SQL Developer, or I will open SQL or some SQL tool to go and find all those, find the table and find what is in the table, what are the name of the columns and all that stuff. But when you have a REPL, what we can do is just try to connect to the database and see what is in there. So what I'm doing here is just, that's the JDBC URL. The first thing that I do is just check that I can connect to the database. So select one, yeah, that returns something. And what we are going to do is using the JDBC metadata API, we are going just to query the database to see what is in there. So we are just saying this is just a small wrapper on top of the JDBC. We are going to check if there is any table called transaction or something similar to transaction. So again, I press a shortcut, that's sent to the Tomcat evaluates it, and we get back the result. So what we get here, if you can see, it's like a JSON-y thing. Yeah, so we see that there is a table, the schema. We have 3 tables, key, ID seek, and transaction. So because it's a little bit hard to read, what we are going to do is just print it in a different way. Yeah? So probably this table looks like what we want for our to get the transactions. So let's look at what's inside that table. Again, we just write a little piece of code. I run that, and I get a list of things. And we see that we are getting some kind of ID, some client, something called type, the currency, the amount, and some timestamp. So we are in this first phase of exploring how the real world behaves, what is in the real world. Now, let's say that we want instead of different currencies, we actually want everything in the same currency, so we can do the summarize properly without having to do any kind of exchange. So what we are going to do now, instead of looking at tables, let's look at if there is any store proc that maybe is useful. So again, using the JDBC API, we check which store procs exist, and we see that there is a store proc called transactions, and there is one called transactions in GVP. So probably this is the one that we want to use. So let's try again, see how that store proc looks like, and if we can call it. So what we are going to do, it's using the JDBC API, we can get on the API to give you the parameters that store proc accepts and the results. So we just generate a little piece of code, which we can copy and paste. And we can try it now. And this is how the store proc, what kind of data does it has and how it looks like. So you may be wondering why you will use a REPL to explore the database instead of using a JDBC specific tool. And the first thing is that if you think about it, what is this thing? This piece of code that we just created. This is the first piece of production code on our application. Yeah. So during the exploration phase of checking how the world works, we have created our first piece of production code. Now, how likely it is that when we deploy this piece of code into our Tomcat, it's going to have an error? How likely is that the return type doesn't work or the parameter is not called client ID? How likely it is? Well, if you think about it, every time that I do this, I evaluate, I send something to the Tomcat, I basically deploying that. So this code is already running in the Tomcat. So it's very, very unlikely that once we deploy this thing into production, we are going to have any issue. The second reason to use a REPL is that because you have the whole language, your production language, the language that you use every day, we can do a for loop. Yeah? If I don't know how to do a for loop in SQL Developer to call a store proc like 5 times. So again, it's just a simple for loop. Yeah? We all know how to do a for loop, right? Now, the third reason to use a REPL instead of using an SQL-specific tool is that if you need to mix this data from this database with data from an HTTP service or from a different or a GMS message, you are in Java, you are in the JVM, so you can write again another piece of code to grab that data from a different place, and then you can mix them together. If you are using an SQL tool and a Postman or a browser, then you end up with completely 2 different tools. And because we are in the JVM, we can get really fancy, and we can use any library that is on the JVM. So if for understanding the real world and how it works, if we needed to create some charts, the JVM comes with a lot of charts. So this is a JGraph. So you can go and use all the tools that we use in our production servers. So this is the first exploration phase to understand how the real world works. And now that in theory, we know that we want to use that this store proc, what I will do is change from my exploration to TDD. I like TDD. So what we will do with TDD, I will switch, and the first thing that I will do is write some tests. So we know that we want to do some kind of summary. To do the summary, we need some kind of mock data, right? We need to mock what the database is returning. So I need, in this case, this is a test. This is how a test looks like. I need here to put the piece of data that I'm going to use during our testing. And I could go here and create the record, and we'll create mock the whole thing. But if you think about it, here, this thing is the result of calling the production code. It's the result of calling the database. So we can just go, copy, and paste this thing here. And now I have a test that just works. So if I run that, we have used the REPL, we have used the results from our exploration directly on our TDD workflow. I will fix this now. So now it works. Okay, so now we are in the TDD workflow, and let's say that for some reason we wanted to ignore any transaction that is of type 101. So I change to my production code, and I'm going to say, okay, I want to remove anything. So if we remove it, this should be 18. And I run it, and everything runs. And now let's say that apart from removing all the transactions of type 101, we want to remove all the transactions that are that have a negative number like this. So again, we will change the test, say that it's 23, we run it, and we can go and change it. I change the production code. Now, having to change and having to tell the JVM to run the test and when to run it, it gets a little bit cumbersome. So we can tell the REPL to keep an eye on any change that I make. And as soon as I make the change, the REPL will go and run the test that could be affected by that change. Yeah, so if I let's make a change, I save, something, the tests are run. Now I go to the code, I try to fix it, that fails because it's 23, this should be a remove. I save it, and the test is run. So I don't need to do anything. The REPL is taking care of checking what tests need to be run depending on what changes I have made. So for example, if I go to a completely different file, and I make a change, and I save this file, we see here that no test was run. And there is no test that was run because this file doesn't have any associated test. There is, if I change this file because there is no test that depends on this file, it doesn't need to run anything. So if you have a really long or a big test suite, the REPL is going to take care of just running the minimum number of tests that you need to run to make sure that things work. So that's another thing that the REPL help us with both mocking the data that we want to use on our TDD, and it's going to enhance our TDD workflow because it's going to take care of just running the test for you. Cool. So let's say now that we have finished our TDD and we need to do the wiring. We need to create that HTTP endpoint, and we need to wire everything together. So the application comes with a Swagger UI. Everybody comfortable with Swagger? It's just like a way of checking your endpoints, your RESTful endpoints. So, oops. So right now we just have one endpoint called ping. So what we are going to do is just add a new endpoint. So to do that, this is an example that we have. We just copy and paste the example. We call it total. We don't want any documentation. We expect a client of type long. And now we just refresh to check how it looks like. There it is. So this is how long it takes to create a new controller. Instead of having to rebuild everything, do some wiring, you know, it's immediate. The feedback that we are getting is immediate. So we test it. We see that we are still not returning anything that we wanted. So let's do the wiring now. So we need a DB, and we are going to call the store proc that we created. So we need the DB and the client. And if I try that now, we are getting the total 23. Okay, so here we are just testing our wiring of getting all the bits and pieces together. I personally, in Java, don't test any controller. I don't see the need of writing the controllers because they should have no logic. So here it's just the same. And again, I just make a small change, I try it out, and it just works. But now again, changing between my code and a browser to test it, it's getting annoying, right? Can we get a faster feedback? Well, the JVM, we know how to make an HTTP call, right? So it's just why we don't tell the JVM to make an HTTP call and just print the results. So, oops. Come on. Here, just a piece of code, that makes the HTTP call. So now I don't need to be switching between one and another. I can just make a change, total, I save it, and here we see the result of that HTTP call. So we are getting a slightly, again, faster feedback because we don't want to be switching between one tool and another. We are always working in the IDE. This is the production code, so there is nothing, there's not a special window. This is how you will package this thing and you will put it into production. Okay? Cool. Let's say now that we have this flow where everything is refreshed automatically, that we can call the HTTP endpoint from within the application. And now what happens when we have some state? Yeah, so I have here a counter, and let's say that we wanted to count how many times this endpoint has been called. So we just add a little bit of code. Yeah, now I save it, and we see straight away counter number 1, 2, 3, 4, 5, 6, 7. Yeah, but what happens if instead of counter we want to call it say count? It has been reset because we are refreshing the application. We are losing the state. And for this counter, probably it's not a big issue, but if you were having some cache or some thread pool or some connection pool, it will be very annoying to have to recreate all that state all the time. So what we can tell is that, well, instead of recreating it, we are going to tell the REPL that this particular piece of state, we don't want to be recreated. So if we make some calls, we see count 11, up to 11, 12. So let's make a change. So instead of counter, we're just going to say C. And now C is 14. And if I make another change, now it's 15, 16. So we can control what's the state. We can control when the state is being destroyed or when it's being kept. And the same way that because we are in the REPL, we can write a little piece of code and just check straight away what's the state of the application. And if you are doing some testing, you can change it. Yeah? So now we are changing it to 1,000,000, and we make an HTTP call and see that things still work. And if we wanted, we can say, OK, now I'm ready to reset the whole thing, and I actually want to start from scratch. So you can start again from scratch. So we saw that we are actually being able to manage the state of the application, keep the state when we want it, reset it, or change it whenever we want. OK? Cool. So what we saw that how easy it is to play around with the language, with the functions, with the libraries. We were writing code, and immediately we were getting the result to know, to see how the thing works. We have to build once, and in practice, you will do that like once, as I say, at least once a week, once a month. We were using the result of our exploration straight away in our test. We have all the libraries and the JVM to go and poke around, queues, databases, everything. And the nice thing about the JVM is we have libraries to do absolutely everything that we need. I'm not going to say that you are not going to get any surprises, but you are going to get fewer surprises for sure when you start the application. We saw how useful for our TDD was that the REPL will take care of running the test and just the test that could be affected by one change. And we saw that we were able to inspect and manage the state of the application. And we did all of this from the IDE, which for me it's a big plus. You don't need to be switching between two different tools. So this is the setup that we had. And if you think about it, this is a socket. So what will happen if we leave that socket open and we deploy our application with our REPL enabled in staging and production? And from our IDE, we connect to staging or production. How many times you have had a production at production. And staging issue, a QA comes and said, oh, there is a problem here. And you think, well, if I could just add one log line in this particular result or in this before I call that third party, I will know straight away what's the issue. Or if you have a cache, if you could look at what's the value in a cache, and with a REPL, because you can go and inspect the state or you can make small changes, you can do that straight away. But who will be so crazy to want to have that kind of power in production? So this is a nice story from the NASA where they debug and fix. And by fix, it means that they make a code change on a spacecraft that was 100 million kilometers away. So they fix a bug in a spacecraft just using a REPL. And I'm not saying that you should be developing directly in production, but it's something that if you have a real problem, you can actually use. It's just another tool in your tool set. So I'm going to add two things that we want to be able to debug and fix staging and production environments, and we want to be able to control spacecrafts. Remember why we want this thing? Oh. It's just 30 seconds. Come on, 30 seconds. That joy and productivity of doing a good work. This is, as I said, this is not exclusive to Clojure. There are videos of something similar in JavaScript, ClojureScript, Elm, Groovy, Python, iOS, Android, Unity. There are plenty of them. This is the code I have been using during the talk. I encourage everybody to look at the first presentation. That's what got me really interested on finding a better workflow when I'm doing development. And that video is just amazing. And with that, I'm done. Thank you very much. Questions? Questions? Any question? One question?
Are there any limitations with regard to the language that you can use?
Each language is going to have different limitations. So, for example, in the case of Clojure, there are some limitations, but they are very limited limitations.
What I mean is, can you use Python or can you use, I don't know.
So Python, I have seen some demos of Python now. Python usually build scripts, and while in Java, in the JVM, we have this stateful thing that has to be up and running forever. So the workflow is slightly different. The demos that I have seen in other languages, they usually run a whole script or a whole file, while here we are just running one particular piece of code, just one expression, and then you do another expression, and you can pick up just one bit within one expression just to run, which makes it a little bit easier, a little bit simpler or a little bit more powerful from my point of view. But each language, depending what you do, depending on the language, you get different capabilities.
Thank you.
Anything else? Cool. Thank you very much, guys.